So today, welcome back to the R4DS discussion for the DSLC, the Data Science Learning Community Book Club discussion. We're going to be talking about chapter number 19, joins, and DJ is going to lead us today. And what we're going to do is we're going to keep sticking with our kind of general structure that we discussed, open it up for any challenging topics that people want to talk about, and then start digging into some of the exercises for today. So, DJ, I'm going to turn it over to you and we'll go from there.
Yeah, thank you so much, Colin. Can you see my screen, right?
Yep, sure can.
Yeah. Can you right now? Can
Yep,
you see my?
I can. Yep, you're good to go.
I think I need to edit. Can you see my screen, right?
Yep,
Sorry
I
for
can
that.
see it.
Yeah.
Yep,
Okay.
I can
Awesome.
see it.
So right now, like the topic is joins. I'm very interested to like learn about this, and I mean, I know like I use joins in SQL, but I was like thinking about R, even that's the same. So yeah, joins is a topic is like to combine like two data frames like our tables using matching the rows in the two tables with the based on their columns and rows. So there are a few types of joins in the topic, so we can be discuss. Yeah. So yeah, I said like a join is an operation of joining. Join is can be classified into several like we have types like a inner join, left join, right join, full join, semi join, and anti join. We can be explained in the like with the examples in the like further. And when you say about the keys are the variable used to connect the pair of data frames like a data tables in the join. So basically like columns. So I'm gonna yeah. So we have like a two like a main keys in the like table like they are like primary key which is like a unique identifier in the each data frame like which can be a, like a foreign key for the another table. If you I can explain you in that like flights data set, like considering a flights data set, I can explain you more about like primary key and foreign key over there. So this is about little about thing about like a primary key and foreign key. And if you see the like flights data set we are using right now for the example, so if you see the time hour is like one of the primary key here. But when you go to the weather, it's a foreign like a foreign key for the sorry, it's a foreign key here in the flights. Where it goes to the weather, it can be like a primary key, which is like unique identifier, which helps can be a foreign key in the other table. So if you see like in the planes data set, the tail number is like a primary key for the tails for the planes table, which can be like a foreign key for the flights data set. So this is the relationship between the primary key and like a foreign key. And if we go next, yeah, I mean, I recently got to know about the surrogate key is a single variable which a variable which is a unique identifier, usually like a numeric or a alphanumeric that is artificially assigned to a record in a database, like which is like considered as a like acts as like a primary key. So I can explain you in that in the example, like in the practice exercises. So I just want to explain like the types of joins. The left join is like something which only keeps a matching rows from the both tables. Sorry, inner join. And the left join is like keeps a record of all the joins on the left table matching rows from the right. I have a better picture of showing here. Yeah, if you see the inner join, it only keeps the like a matching rows from the both tables. So x like x1 y y1 and x2 y2 will be matched because it's only keeps common rows from the both tables. If you see like a left join, keeps all the rows from the left table and rows matching on the right table. If you see the rows in the left is x1 and y1, x2 and y2, and the x3 has like a an A value, so it's matched with X3. The 4 will be eliminated for the left joint. If you consider the right joint similarly with the left joint, but the right table will be the rows and it will matched with the left joint. So if you see like a y1, x1, y1, and x2, y2, that's all. And the fourth table will be the common in the right joint, right table, like y table. So that's about right joint. And if you see the full joint, keeps all the rows from the both tables. Like the all rows will be matched and like it will be it is like adding the both rows in one table. So that's about full join. I can show you the examples here.
Well, I
Uh,
think I think we'll probably get to all of the different joins. Well,
yeah,
yeah, so yeah, you can go through the examples. I'm sure we'll get to the joins when we get through some of the exercises, but yeah, if you want to
yeah,
go ahead and share your kind of examples that you have, that would be good.
yeah. So when I say like the inner join,
Can you increase the font size a little bit,
yeah,
please?
sure.
If you go command plus, it should increase it. So if you go command plus, it will.
Yeah,
Yep,
can you
there
see?
you go.
Thank you. Perfect.
Awesome. So yeah, I loaded like a library for the NYC flights data set. So right now we are applying this example for the inner join by it's all in the dplyr packages. And if you apply like inner join for the airlines table by considering like a primary key as a carrier, it will pull all the data matching on the rows with the both tables. So if you see this is a like a data both are matching in rows in the both flights in the airlines table. And if you see the left joint for the same table, like at the flights data set, uh, by considering the like a by tail number, it shows all the data set which are matched from the left table and the matching the rows from the right table. And this is the planes data set for the right joint using the right joint function. So this gives all the rows from the right table without matching in the left table. And if you see the full join, so while joining this full join, we are taking a set of list of columns with the origin, year, month, day, and hour. So where we can see the like those as a like a weather factor like factors which we are pulling the data from the flights table. So these are the like columns which are like keep all the like rows from the both tables. And the semi-join. Semi-join is like keeps only rows from the left table that have a match in the right table. So it shows. I can have a picture for that. I can show you in the next slide. For the semi-join, it's interesting actually. So the semi-join have like a keep only the rows from the left table that have a match on the right table. So this is the data set for the flight using the tail number. And if you see the anti-join, it's like opposite to the semi-join, which keeps which take away the commonly matched rows in that both tables, and by excluding that, it will like push the rows that are not matched. So it's about anti-joins, and uh, we have like a little explanation of a flight's inner like a flights when have an inner joint. So this is the number of flights which are flight in the that year with the which airlines have a highest number of flights with that. So I have like a little GG plot for that. And yeah, these are the exercises I want to mention in this joints topic. So Colin, do you want me to show the
No, I
questions
think that was
first
a good
or
overview of all the different join types. I think it's a good opportunity here to like open it up for any like additional conversation about like complicated topics. I mean, I have a
yeah,
couple things that I thought were I don't know if they're worth additional discussion before we dig into the exercises that we identified, but um the first one that I had was like cross joins. Like getting the Cartesian product, which I thought was interesting because I went and did like a deep dive to figure out a little bit more about like where would this be useful, because I know in the past when I've learned like cross joins in SQL, people are like, don't do this in a database because it could explode the size of your tables that you're creating. So I thought that was kind of interesting. Um, but then the other one that was like a little bit harder for me to really understand was like rolling joins and overlap joins. Like those were like, it took me a little bit to really dig into those. I don't know if we want to spend more time talking about it, but I did want to highlight that I came across this article or this blog post that made it a little bit more accessible to me about where they would be useful. So I don't know if anybody wants to take a look at this later, but um, I don't know. That was a really hard struggle for me, was the inequality joins and how to actually use them. I don't know if anybody else wants to talk more about those, but
I actually had two applications. So the rolling join is the one that gives you the closest value to something. So it's an inequality, but it gives you the closest one. And so I am working with student data, and some students actually do more than one program. And I wanted to like get the subset of courses they took for one program and then the other program. And so I had the enrollment data, when were they in one program, when were they in the other program, and which included dates. And then I had the dates when they took different courses. And so the rolling join allowed me to basically then sort it by the program and get it together that way. That was very helpful. And the other thing I found very helpful with an inequality join, I try to get like an idea what the gender composition at a certain grade average is. And so I made basically a sequence which was from all the grades like by 1 point steps. So it was like 199 and so on. And then I did an inequality join and wanted only the students which had an average higher than that. And then I could use the demographic data to calculate the average. And in that way, the students that had 100 would be in any of the joins that are lower than 102, so they would still be represented. And that was very helpful to calculate. So those were kind of applications for those joins for me that were very powerful.
yeah, that's where I was thinking with like inequality, because the book was just like, because what you were talking about made sense because you're basing it off of using like your logical operators, less than, equal to, and I was like, oh, that seems very useful in certain cases. But then the book was like, there's no useful cases for this, and I was like, I think I could think of a couple things like you just said, Stefan, where you would probably want to join on a key based on like if something was higher. But I guess where they're coming from comes from like going back to the idea of like primary and foreign keys, like having a very clear like primary and foreign key, and then using that join to on the keys that's for the tables. So that's where I think I got a little disconnected with it. Um, but go building on like the rolling join, it's kind of the same thing in that blog post, because we work in media, we work in marketing. It's the same thing. And the example that was shared here was like, say you wanted to promote a YouTube video and you put like specific marketing around it, but that marketing campaign only runs on a certain date, but that video is available every single day and you get views for that every single day. And so what you can do is you can use a rolling join to like take an average of like 3 days after you run your campaign. And I was like, oh, that's interesting, because then you just use the join to get that data to look at the data that you want, and then you calculate that aggregation, which I thought was pretty slick. So but yeah, there are examples with like birthdays and like office parties. I was like, I see the utility in it, but it took me a little bit to really like understand, okay, these are a lot of steps to get the answer that you want. And then when they did oh, well, just so you know, that rolling joins, there's an issue with it. So you have to actually do an overlap join, which got a little confusing for me. So
Yeah.
I don't know. Emphasizing that, not really giving an answer to it, but just emphasizing that that was complicated for me. But like when it comes to joins, it's like left join, like So left join is probably the one tool set that I lean on a lot because it's usually trying to pull data from another table into a table that you're using. So maybe sometimes a semi join. And I shouldn't say that anti-joins are pretty useful because, and DJ, you can correct me if I'm wrong, in SQL, I don't think there's a true SQL anti-join, is there in SQL?
Yeah.
Is there?
I don't think so. Yeah.
I'm not sure. I'd have to look at that. I think if I've looked before, there's not like a true anti-join like R has available, but anyways, cool. I'll turn over to you. I've already hijacked this enough. You want to start talking about exercises, DJ?
Yeah. Just share this. So I just want to share this like the semi-join this thing for like a graphical representation of it. Like a semi-join helps us like take the common rows which are both matched in the both tables, whereas an anti-join which excludes the both match and like gives the like rows on the like left side. So yeah, that's what I was on to talk about this about the semi-join and anti-join, and we can get into the exercises. Mm, Yeah, sorry. So yeah, if you see the problem you're Colin, do you want me to show the question so that it makes sense, like what problem you're solving?
Yeah, you sure can, or you can just like explain the problem that we're trying to solve and then just share like what we are, just share the answer, and we can parse through it.
Okay.
You're driving, so you do what's best.
Yeah, I was seeing the questions for the.
I'm also going to share a
Yep.
link that is animating the joints. I don't know if you know
Oh,
that. It's from Garrett Aiden Bowie. I probably totally
Oh,
butchered his name.
this is awesome. Oh yeah, +1 on this. Thank you for sharing.
yeah. So if you see the like exercises for the joints topic is like we are considering the first question about like the so the question is let's get the question. Where is it?
I can read the question too, and then if
Yeah,
that's helpful.
yeah, if that helps, yeah.
Yeah, so I'll read it and then you can kind of go over
Yeah.
what you were covering here. So so Stefan, just so you know a little bit, just DJ and I just identified a couple that we thought were useful. I mean, we don't have time to cover all of them. And some of them, so we thought the more coding ones would probably be more beneficial than the ones that are like more conceptual. Um, so the one that we're thinking, that first one is number 3 in the first one, which is the year, month, day, hour, and origin variables almost form a compound key for weather, but there's 1 hour that has a duplicate observation. Can you figure out what's special about that hour? We picked this one because I think there's some really interesting conceptual things that we can point out to. But yeah, go ahead, DJ.
Yeah. Yeah, that special hour is like when the clock it's a hour when the clock rolled back to the standard time after daylight saving. So we are talking about that time. So if you see the like we are considering like whether data set and counting like a year, month, date, hour for the origin and arranging it like a descending order so that we can see that like a special hour uh, which uh, which is like the daylight saving one. So this is the solution for that question is this thing. And
You can, by the way, in your code, you could just add to the count the argument sort equals true, and then it automatically does the descending sort by n. So it's really convenient to have it just. It has to be no, just at comma at the end after all your after all your variable names, just comma,
okay,
and then sort equals true.
I can delete this.
Yeah.
Yep.
And the pipe above, yeah. Try it if it works, but it should work.
Yeah, it
Yeah.
works. So
I
yeah,
just
this
recently
is the
discovered that and thought it was so nice.
yeah, that helpful actually. Yeah, that's a solution for that like special hour. It is mentioned about is like the daylight saving one, where the hours are like rolled back to one. So yeah, and the second question is
Well, before we go over that one, I think this one, and this was a reminder to me, and again, if I'm grandstanding or whatever, and people already know this, I thought this one was really good because it's just a reminder of the conceptual aspects of like, how do you define a primary key? How do you define a foreign key? Well, not really a foreign key here because we're not really doing a join, but it really does a good job of emphasizing like a primary key is this. It uniquely identifies a row and it has to have a value. I think those are the two characteristics of it. Because like some of the data that we work with sometimes, we either have to create a surrogate key or there is no key and we have to use variables that are already in there to create, I think if it's a natural key, that's the term. Like if it's you're using already available things in there that are not that will necessarily do excuse me. I get confused when it gets into like the deeper aspects of like a natural key and whatever. But yeah, I think this one was good because it's just it emphasizes that thing about like what are the characteristics of a primary key while also emphasizing like how do you verify if it is a true primary key because you might come across data that does not have a primary key available. We all don't work with relational databases that give us that stuff. And so it's nice to remember those tools of like counting can help us identify if we do have a true primary key. But again, I'm probably grandstanding because most of you probably already know that, but I just wanted to emphasize that point again.
I actually wanted to ask a question about that, and I don't think there is a universal solution. So I work with a data set that's like processed, and I don't have the original data set, and I don't know the data provenance, how things were combined, but it's basically not normalized data. So I have like all this NA values in there, and it makes actually thinking about the data sometimes really hard because there's so many columns. So I was thinking, can I break down my table into like subtables and normalize them? But there doesn't seem to be an automated way. So you would have to do this manually. You count, do you think whatever, is your unique key, you call a distinct on it. And then if you count, there should be no duplicates if you're correct about the key. But I was wondering, are you aware of any automated ways like that? Or have you encountered that yourself, that it's annoying to have too many columns all the time and then be like, yeah.
Yeah, so there's a couple thoughts like if I'm understanding the problem that you're addressing, like, and I've never done this myself, but I've seen this before where like if you don't have the ability to create a surrogate key, but you have these columns of data that you know are not going to have any missing data, you could concatenate them together. So if you knew that you had specific columns that could uniquely identify the row and you just want to combine them, just combine them as a string using dashes or whatever. As long as you knew that combination of columns would result in a primary key, then you could potentially concatenate them into one column and then see if there's any like if there's any match or additional ones. I've seen that before. I've never done it. Um, but I've seen that before in some of the stuff that I've read regarding that.
Okay, cool, thank you.
I'll see if I can find where I've seen that before. It's a very SQL database thing that I've seen somebody do it somewhere, but I'll see if I can dig that up.
Thank you.
yeah. So the second question is like finding the 48 hours like over the course of the whole year that have the worst days, like worst delays. It has the weather data. So can you see the pattern? So it was talking about like in the whole year, which was the like worst delayed flights had happened. So if you're taking like a flights and like joining with the weather data, like using the left join, matching that the selected like a origin, time hour, and temperature and wind speed, and I think I don't know VSP uh, and the precipitation. So from the weather table using the left join and grouping by the year, month, day. So if you see that like the worst date of the in the like in the worst like a 2 days, like it's a 48 hours. So I just mentioned like a 2 days. So if you see, like I can summarize the depth delay by like averaging of the departure delay, and like doing like the number of count and average wind mean and average. I think VS is like a wind speed,
Visibility.
uh, visibility. I think so. Yeah,
Yeah.
and average precipitation. And when you take it like into the worst, like this the variable, so you can see the like in the worst days of the top two in the day, departure delay is because of the precipitation and the wind speed. High wind speed causes the delay in the flights. And if you summarize the variable, you can see that the wind speed is very high, and the reason for the delays in the flights for the whole year. So yeah, the question is about like finding that the reason for the worst delays is the high wind speed. And yeah, high wind speed is like the reason for the delay in the flights. Do you have any questions in this problem?
So
So,
to give a head,
oh,
oh, go ahead, Stefan, go
no,
ahead.
you go ahead. No, please.
Yeah, well, I just want to give a little bit of context. So like we we also went and tried to find the solutions too. So we were also like trying to figure out the problems, but then we also came across the solution guide that gave us some of this. So some of these answers are going to come from here. So I got to give credit where credit's due. So when we start parsing these apart, because we tried to find the updated solution guide and they didn't have them. So this is actually like another solution guide that we've kind of leaned on a little bit to kind of parse these apart. Um, so yeah, giving credit where credit's due. But like, yeah, what I think we could parse this apart a little bit more, this solution here, because this comes directly from the solutions guide that somebody put together. Um, to figure because I don't know if this was the best approach I think it was a good approach. I really liked how they summarized. So go up, DJ, a little bit. So if you
Yeah.
go up, scroll up. So I did like how they summarized and they used like an average to calculate these summaries for the average departure delay, average wind, average viz, average precipitation. And then did the top end too based on departure delay to see if there was a relationship between like these weather speed or these weather or these aspects of the weather to see if there's any patterns. But I'm not necessarily sure if this tells you the worst 2 days, but I don't know. So Stefan, what was your question or what was your comment?
The worst 2 days. So I was curious if, and this is more a statistical question. I would argue you should take the median and not the mean, because otherwise, if you have for whatever reason an extreme outlier, it's just going to pull it off. I don't know if that's an issue in this data. That was just for the delay. I probably would first just determine the day on which is the worst delay and then use that to do the join, because then it acts almost like a filter, right? You do an inner join and then you have only that information and then can look what happened weather-wise. Yeah, but I mean, this kind of wraps it up into one single step. So I don't know, this might be better.
Yeah, when I approached this, that was my thought was like, okay, what I would do is, like you said, like rank the days that were highest on departure delay and then do some type of inner join or do like a left join and then look at the weather for that. Um, I mean, we can try that and see if that's a little bit different than what was concluded here. But that's up to y'all if you want to keep digging into this one or if we want to kind of move on to the next one. What do you think, DJ?
I mean, anything is works for me. Like we can dig into it, or
Um,
we still have time. So yeah, it's up to you.
uh, well, we have a couple more questions to go through, so maybe we kind of like move on. We kind of talked about it. I did want to point out one thing with this one solution that I thought was really interesting is just like the idea of like doing this like nested pipe within your join. I thought that was really useful where, where you're doing weather. So you have the left join here to bring in the weather information into flights. I thought this was really interesting to do like the select statement off of whether to limit the amount of columns you're bringing in. So I thought that was kind of a neat little trick that I was going to pull from this. So, all right. Yeah, let's just go to the next one, DJ, because we have some other ones that we want to kind
Yeah.
of look at.
Yeah. The next question is like imagine you found like a top 10 most popular destination. So how can you find all the flights to those destinations? So it's like finding like the top 10 destinations in the year, and how do you find the all those flights? So the code for that one is here. So we firstly finding flights data set and mutating with the number of rows and using like a dot before equal to one. So we can find that into the like a flights two, and in that we can put like a count function to destination and sort equal to true. And we're just using like we needed like a top 10 one. So the top 10 destination will be shown here. And in that, using a inner join with the flight and join the destination is equals to destination, we can see the all the flights which are reached to that destination have a like a highest like a most popular destination. So yeah, this is like a code for that. And joining the dataset can be uh, yeah, that's like a top 10 destinations. We are using inner join mostly for the to calculate the from the flights to. And yeah, does anyone have a questions?
My only one about this one, well, my only one about this one was it took me a second to remember the difference between an inner join and a semi join because at first I thought like a semi join would be the right one to do here. So I had to rewrite the definitions so that I kept them straight when I was putting this together and looking at the solution. But like the semi join is you keep all rows in X that have a match in Y. And then an inner join is only keep rows that occur in both X and Y. And so I wanted to make sure that the inner join was correct in this case, which I think it is, because I think a semi join would not give us the answer that we would be looking for. I can actually talk about it, but yeah, that was the only issue that I had with it was just remembering the difference between inner join and semi join, and if inner join was actually the correct way to do that.
Isn't it? I was maybe I have a wrong mental model, but I think both are the same, and the difference is if you get the columns of the right side of the other table.
That's what I was also wondering too, is if it was the same answer, just depending on which way you put in your table, right? If you go flights first or destination first. I know we could try and confirm that, but that's what I was wondering too, is if they're the same thing.
Okay, should we try it and see if we get the same result?
Sure, let's do it. So DJ, for this, what you'll do is you'll just take the same, well, what you can do is you can go flights piped into,
Okay.
if I'm
Do you
thinking
want me
about
to
this
use that?
correctly, I would just do it in the same code chunk right there.
Okay. So yeah, flights.
Take flights. Yep, so start with flights. And I think you have a typo in there, so flights. Yep. And then you do semi join. Semi underscore join. And then this one you use top destinations. Or top dest, yep. And then you would go comma join by. And then you do destination equals destination equals destination. I have to get used to using join by now because that's not what I was used to using. Go ahead, Stefan.
If you have equal, you can just write dest. If it's the same on both sides, you can just write
That's
dest.
right. That's right. Yep.
I mean, this way it's more explicit the way you have written it, but to have it more concise.
Do we? We do need dest in here though, don't we? I was just thinking, do we even need it? But we do because it will probably join on. Yeah. Okay.
Do you want me to run the code?
Yeah. It's the same amount of rows, 141,145.
Yeah.
So, okay, so if I can summarize this of my understanding, a semi-join and inner. So the only difference between a semi-join and inner join is which columns are retained based on your X and Y tables. That's the only difference.
I think so. And I mean, in this particular case, it also doesn't make any difference in the output because our one table has literally only one column, right? Oh, no, it also has the count. But if you would get rid of the count, yeah. So sometimes I did this awkwardly because I didn't think of filter joins and do just take a single column from my right-hand table to do the join. And then, but these filter joins are very powerful. And I think is this true? I think a filter join is faster than if you would filter on a variable. So if you have clever ways of doing filter joins, you can like even have speed ups because that way. I might be wrong, but I feel like joins are pretty optimized.
I think you are correct in that statement because with a filter, it has to go every single row. Like it would have to scan through every single row. A join, you don't have to do that scan. I mean, I guess it would depend on where you're applying it, but I do think that's correct, at least from like a database perspective. Like I've seen that and heard that before. Like if you do joins, joins are optimized above like actually doing a filter, and the reason being because it doesn't have to it doesn't have to scan the entire column. So um this is interesting too, because you bring up that point of like, because I think that's where like joins get kind of confusing sometimes. Because on a cross join, and I came across this when I was digging more into this, but somebody said all joins are built off of a cross join. It's just that you're using conditions to determine what gets retained. And I don't know if that's a true statement, but I kind of thought about it, but it sounded true to me. I don't know what y'all think about that.
Yeah, I wonder if it's true. When we were looking at the equi joins, I was wondering if under the hood they first do a cross join and then do the filtering on the top of that. I wonder, I'm not a programmer. I wonder if that's efficient because you would need a lot more memory, right, to do the actual join when you create a very large object because of the cross join. So that would be, I think, the only limitation why you would try to avoid that. If there are other ways, but I think that would be a limitation because otherwise you're like creating these gigantic objects.
Well, because I was like, if you go back to that, like the blog post that I shared earlier, like so supposedly dplyr didn't have the functionality to do non-equi joins as far back as what I think 2021. So this is like
Yeah.
a new feature set. And so the person's solution to do a rolling join here was to do first, I think it was a cross join or something, but they do some like join and then they add some conditional logic to it to actually perform the equality or the rolling join. So
Yeah.
yeah, the non-equi join stuff was like this was like the completely new stuff to me that I was like mind blown by it. But let me see if I can pull up the code that they have for it to actually pull it off. Because they do use dplyr, but then they use some logic in it to they do a full
So,
join and then they filter it. So here's
yeah.
what they have.
And it makes sense in the chapter they explicitly say what the conditions are you basically filter on, right? So I mean they say like whatever the different unequal choice are, you probably can just then after you have your cross join do the do those conditions and filter on them.
Mhm, mhm.
Oh yeah,
Cool. So they first do a full join and then they do like a filter where they do like the view date is
Mm,
greater than the promo date, and then the view date is less than or equal to the promo date plus 3.
cool.
The other thing, and I know this is a sidebar, but like um I think like another concept that also gets talked about too is like the concept of fuzzy joins. Like I don't know if anybody's ever come across that. There's an actual like package for doing fuzzy
Yeah.
joins. That whole thing is super confusing to me as well. Like the idea that you can like filter, you can do like a filter join based on some range of values that like, yeah, I think a long time ago I tried to do that with something because I had like date ranges for certain thing. And then like if it didn't fall within that date range, then it needed to be taken out. Really bad solution. Really confusing. And I'm glad that we dropped that type of reporting because it was like I couldn't guarantee because I couldn't understand what a fuzzy join was actually doing in that case. But total sidebar, fuzzy joins weren't talked about in this chapter, but you can definitely go down the
Yeah,
rabbit hole if you didn't want to.
I think the only really a reason why I looked into this once before was because of strings, and you have like misspelled names or something like that, or you have an ID and there's a typo in the ID. I mean, this is dangerous, but let's say your ID should have 8 digits and it only has 7. And now you're like, okay, how I'm going to match this up? So you could probably do a fuzzy join to do that. But I don't remember my use case anymore. But it was something like that because it's so annoying, like with
It
typos.
it just goes back to like, and I know like when you get into the analysis part of it, sometimes you're just given the data and you don't have the opportunity to modify your data, but like it goes back to like just basic data integrity,
Yeah,
like system design to a point where it's like there's a reason why we follow these conventions because later down the stream you might have to do these like ridiculous things to try and get anything to work. But yeah,
yeah,
cool.
it's like annoying stuff. I worked only on small data sets, but for example, we do surveys with students, and to give them like a bonus for marks because they participated in the survey, they give their ID, otherwise, and they do this separate from their answers. But then they do a typo, and then you're like, okay, who are you? And that's just because we don't have any data integrity when they fill out that form, and they should be, right? It should be like the subset of students should be the only possible values, and it should give them an error when they make a typo. Yeah.
Oh boy. Cool. Yeah, so what time we at? Oh, so we got about 15 minutes left. So DJ, what's next?
The next question is like, what do the tail numbers that don't have a matching record in planes dataset have in common? So the question is that,
I think we can skip this one because when you and I were talking about this, DJ, I think we
yeah,
we answered this question last time. It has to deal with that the certain airline doesn't report a specific tail number, and this is just a
So
confirmation of
this
it.
is the same like the NA, but how would you show that easily? Like, I'm curious how you went about it to find, like, you basically need a correlation or something, or I don't know. How would you,
yeah.
what would be the data science way of instead of checking each individual variable to quickly get an idea if one of the variables correlates stronger with this? Do you know what I mean?
Yeah, and this was the solution that we came across and that we were picking apart. So this isn't necessarily our solution, but this is how somebody else did it.
Yeah. So this is the code for that question actually. Yeah.
Yeah.
So yeah. The next question is like,
well, wait,
add.
DJ, let's pick it
Yeah.
apart because let's see if we can pick this apart a little bit to see how this person did it and see if we can answer Stefan's question here.
Yeah.
So they've done the anti-join like we've done in the past, and it looks like they filtered out NAs. Is NA? Oh no, they kept NAs because they okay, so they kept NAs, and then it looks like they took out the tail number. And then DJ, can you highlight and run from like 135 to 139? Yeah, just run that. I'm curious what that looks like. So what's going on here? So they basically took all character and pivoted it longer. Sorry, I'm going to ask you to do something else. Can you just go from like 135 to 138 before we do the pivot? Okay, so what are we doing here? So what are the character? Can you scan over and tell me what the character variables are? What variables are of type character?
Okay.
So the black triangle.
Oh, I see what they're doing. They pivoted long so they can facet it later, right? It has to be in long format, and that's why they take all the character ones variables because they look for correlation there. And so to
Mhm.
pivot longer, only those columns they do that. Does that make sense? Yeah, I think that makes
Yeah,
sense, right?
yeah, that makes sense. Oh, yeah, because they have the facet wrap. They're gonna
Yeah.
roll it into name. Okay, that makes sense. Okay, and then they do value, and then they create a bar chart, and then they facet it by name. Okay, that makes sense why they're doing it. Okay, so you could probably run this whole thing. I see what they're doing now. And it breaks it up by carrier, destination, and origin. And then so we have these three variables, carrier, destination, origin, which are all character. We faceted by that, and then you're getting simple count values for each one. And so I think basically it's what it's just trying to this is really hard to see
The other one, yeah,
because
destinations.
destination is really hard to see. But I
See,
guess
and
it really go ahead.
no, it's hard to see. But see, now I mean, it seems like is carrier the answer? Because there's other, like, if you look at the destinations, there's 4 destinations or 5 destinations that also seem to stick out quite a bit, right? So why is the carrier the important part here? It's like
Uh
it doesn't really give us an answer, right? Well, why certain tail numbers are missing is for whatever reason those destinations higher. I don't know why that would be, but
yeah, because the question kind of prompts you by saying there's one variable that would explain 90% of the issue.
oh, that's
So
true. Okay, I see. Yeah.
but you say that, but I'm thinking when you say that though, like why would there be a relationship with these carriers and destination and origin? And my question would be like, would my assumption would be like hubs, right? Like does Delta go out of Atlanta or something like that? And so my assumption would be like the reason why you see higher ones out of here is maybe, I don't know, maybe I'm thinking it, but that's my assumption is like, you know, certain carriers fly more out of certain areas and go to certain places more than other carriers. I don't know. That's what I'm thinking.
So is there some code way to express that more than 90% of the observations?
Oh,
What
that's a
would
good
that
question.
be? Because that would be the interesting part. That would take out our, I mean, it's also fine to look at things like that and then investigate further, right? It's just a visualization, exploration, basically, that helps you. So that's also totally fine. But would there be a more codey way to approach it?
It's having common hint. One variable explains about 90% of the problems.
And maybe
So
there isn't. I'm just like thinking out
no,
loud
I
here.
no, and that's the point of these discussions is to see if there is a way to do it. So okay, let's I'm not looking at the solution here. So scroll up here, DJ, because we know the anti-join is going to give us the NA values, and then we're filtering it by NA. Can you just run 135 to 137 so I can see it? So I'm just wondering. Okay, so that's filtering. Okay, so what if we okay, I'm gonna tell you to do another thing. So 136, let's move the pipe down. So on 136, let's move the pipe. Actually, just keep 136, but just move the pipe down because I want to do something else. Oh, I think I know how to do this. Okay. All right, I'm gonna try this. Okay, so can you run 135 to 136? Okay, so we have this. Okay, so we have this. Okay, what do I want to do? So this is what I'm thinking in my head, and maybe this will spark somebody else to think. So this goes back to like doing like ones and zeros, like doing a mean of 1 and 0. So what we could do is just like identify, convert tail numbers that are present, not present, and then do like a sum, like a summary, counting them up, grouped
Okay.
by carrier. Could we do something like that? I mean, I guess that doesn't necessarily answer the question of like, because we already know going into this that carrier's the problem. Well, no, but then you could do what they did. You could pivot it, right? And then do the same calculation, but group by name, the variable. Okay. Okay, DJ, this is what I want you to do.
Yeah.
So do a mutate. Well, no, because we still know carrier. Dang it. Sorry. Actually, do what they do with pivot longer. Do what they do with pivot longer. So take the 140, 142 and add that to your pipeline. Okay, add that. Okay, then do pipe. So pivot longer. Okay, so I want to do that. And what I want to do is I want to do a mutate. Okay, so I want to mutate the value because we're going to mutate value. Because what I'm trying to do is I'm going to try and do like a case when or an if else to say like if it's NA, give it a 0. If it's not A, give it a 1. So so what you could do is go value equals, maybe we just do an if else, we don't do a case when, maybe do if else. So like the, yep, if else, whoops, if else. Yep. And then open close parenthesis, then go value. If value comma is dot NA, right, is dot NA. If
No,
else,
it has to go up around the value. The S and A
yep,
has to go around the value.
yep, you are correct. Yep. So take away is, so wrap value in the is dot NA function. Yep. And then put value and then do comma. Nope, not go outside of the is.na function. So outside comma. So is an A. So if it is an A, give it a 0, 0, the number 0.
Like you want me to type 0?
Yep, type 0. And then comma. If it is not A, give it 1. Okay, so then that should convert it. So now we want to do a summarize, right? But we would do a group by.
You actually could just do, I mean, this is now just me being, you could
Go
just
for it.
value equals not is an A value, gives you the same. Then you don't have the is an A if else.
Do you want me to do it? Can I try it?
Yeah, sure.
Yeah, go for it.
Not is an A. And then you can delete all the other stuff. Right? Because that's what we
Oh
wanted.
yeah, because it would give you true false. You are correct,
Yeah.
because we don't have to, because it would just give you true false. And
You
you can
can
get rid of the
delete the
0 and
0
1.
and 1. Yeah.
Yep. Okay. So now what we can do is group by. Group by. And we would group by name, right? Name. And then we could do a summary. Just group by name. No, just group by name and do a pipe. And then do summarize. And then we would just do a mean. So the summarize, well, what do we want to call it? We could just call it name. You can just go name. Just do name equals mean of value.
But shouldn't
Okay,
it be that one? Because will any of these be missing? The
well,
pivot would also. Sorry, go
go
ahead.
ahead. Well, I'm just thinking because it is the is.na, is that that's gonna convert it into true and false, right? So everything's gonna have a value, nothing. But my question is NA gonna throw us off? Is NA gonna be contagious in this case? I don't know. Sorry, I might be overthinking it. What were you thinking, Stefan?
No, but right now, what are we trying to do with the value part? Because everything ideally is one, right? Because there should be no is an A in the other columns.
Mm-hmm.
You know what I mean? And the pivot
Oh.
longer will also automatically drop anything where you don't have a value, I think. I think you can turn that off, but
Okay. Yeah, we can try it and look at it and see.
I mean, let's just look at the output for now, like
Yeah.
just to see
Oh.
if I'm correct. I think it will be probably just one for all three. And you can just hit Command Enter or Control Enter. I'm not sure if you're on Windows or to run the whole thing.
Yeah.
If your cursor is within the block.
You are right. It is.
Oh, one is off. Which one is it?
Did we
Why
group
don't we
by?
get?
Oh, because in our summarize we gave it name, so maybe it needs to be value. So in summarize, do that as value. So in summarize, you have name equal, save that as value or mean value or whatever. So you have name,
Yeah.
change that to value. Yeah, that's fine. And run that. Okay, so scroll down.
Tail numbers are not complete. Okay, there's definitely. Why did it? Oh, the tail numbers are characters.
Oh, they would have to be because it's like N9053, something like that,
Oh
right?
yeah, I see. Oh, I think in the original solution they dropped the name. I think do they drop the tail number? Because was that plotted? I don't think so.
Yeah, they did drop tail number. Yeah,
Yeah.
because they do the select minus tail number. But do you see what I'm trying to do? I'm trying to I don't know if this is answering our question, but I'm trying to do what they were doing, but I'm trying to get a percentage.
So right now, one of the things we cannot do an anti-join first because it filters out all the things that don't have a tail number, right?
Okay.
We want to basically compare the ones that have a tail number versus the ones that don't have a tail number. So that has to be a left join, I think.
Okay. So just do left join. So instead of an anti-join, DJ, do left join.
And then when you group by, you add the tail number. No, you. Let me think. We want to compare the ones that have a tail number versus the ones that don't have a tail number. So it would be is an A tail number. Like those are the two. Can we group by and yeah, that should be possible, right? You can you throw in the group by is an A and then tail number as an additional.
We can
In the group
try.
Yeah.
Comma tail number, right?
So yeah, comma and then is an A tail number.
Is dot and then tail number.
Yeah. And run that. Oh, why is that? Object tail number not found. Because why?
Longer is dot character. Here, just a second. I'm gonna have to jump off here. Just 1 second.
Oh, I think we are also at 1 hour, so I assume we're gonna wrap it up here. Pivot longer. And also, I'm also off for just a second.
Yeah.
Okay, sorry about that. I had to take a phone call. So,
oh, I know why tail number is gone, because it's also pivoted. So in the pivot longer, exclude, does that work that we say exclude tail number? But because we basically don't want tail.
Longer. Did you hear me?
Yeah, I can hear her.
Yeah, okay. So in the pivot longer, I think we have to exclude tail number.
oh, okay. I see what you're saying. So I see what you're doing. So pivot longer. Where is dot character?
So we have to exclude from the pivot longer the tail number because we want it to still be a column. Right now it becomes a name, the tail number, and then in the value, whatever the tail number is, but that's not what we want. We want it to stay a variable. So we have to exclude it. I don't know how that interacts with, like, can you just add minus tail number at the beginning from pivot longer and then where is character? But I don't know if that both works. Like, can you exclude something and then add it by where? I don't know how the pivot longer works, frankly.
Yeah. That one,
Do you
I think what
want-
we'll have to do is like ours. There's probably like something that you can try it and see, just see if it works.
Pivot longer can combine year, double, and carrier. Oh, I think what happened is the first argument, like if you go up again, in the is where, like now the minus tail number is the first argument, which tells you which columns. And so then it ignores the where is character. So now it's trying to pivot everything but the tail number. So whatever, I don't know, we can be just explicit and do like C, like do a vector and a subset just the columns we want explicitly, like whatever the character columns are. So the destination,
Origin,
origin,
and carrier.
Yeah.
So DJ, just clear out pivot longer, clear out everything in there. Yep. So do C.
C, yeah.
The letter C.
C?
Yep.
And then open parentheses. And then carrier. No, it just, you don't have to.
Yep. Carrier, comma. Destination, DEST. And then I think it's
Origin, I think, was the other one, because it was just 3 airports, right? It was the 3. Okay. Let's see if that works now.
Okay, we got something. True, false, true. So they're all value is dot NA tail number.
Something I must be. Oh, and now I think it's the pivot longer which drops the NA. So go to the pivot longer, and I forgot. I assume it's dot drop equals, but you have to look at the documentation. So if you look at the documentation for pivot longer, I think when the value is NA, it will just drop them.
So we might have to open it up. I can look it up here. So what are we looking at? Pivot longer.
You can also do function 1 to get the documentation. Yeah. F1.
Columns vary names to names repair. Yeah, values drop NA. It defaults to false, so values drop NA.
Oh, okay, then that's not it. Okay, I don't know. It's also now after the hour. I don't know if the
It really just you see what I'm trying to do though? Like I'm
yeah.
just trying to do what they did with the pivot longer, but I'm trying to like calculate like just doing like a mutate, change it to like a 0, 1 kind of thing, and then just like summarize it. And then we could see which variable is missing the most, is the way I would approach it. I just can't figure out the syntax to get there.
Yeah.
So cool.
Okay.
All right. Yeah, we're at the hour, so we're 7 over. So I appreciate everybody staying over. Yeah, we'll tackle chapter number 19 or no, chapter 20 next week, and then we'll see everybody. So have a good rest of your day.
Yeah. Thank you so
Awesome.
much.
Thank you.
All right. So yeah.